So let me quickly revise the concept of hydrocarbons. The word hydrocarbon is formed from two words, hydro and carbon. And so hydrocarbons are those compounds which contain carbon and hydrogen, like alkane, alkene, and alkyne. A in alkane, E in alkene, and Y in alkyne. I arrange them in alphabetic order, and so I like to say alkane is the number 1, alkene 2, and alkyne 3. In alkane, there is only one bond between the carbon atoms. An example is ethane. In alkene, there is a double bond between the carbon atoms. An example is ethene. And in alkyne, there is a triple bond between the carbon atoms. An example is ethyne. And so we can easily spot out hydrocarbons by knowing the single, double, or triple bond they contain. So we shall now look at functional groups. But first, we must understand what an alkyl radical is. Consider an alkane like methane. In methane, carbon forms 4 single bonds with 4 hydrogen atoms. And so if I remove one hydrogen atom from methane, then it becomes an alkyl radical. So this is an alkane and this is an alkyl radical. The latter is represented by R dash. The dash implies that it can form chemical bonds with other species. So, if an OH is attached to the alkyl radical, something new is formed and it's now called an alcohol. And so, OH changes the function of the alkyl radical. Similarly, if COOH is attached to the alkyl radical, again, something new is formed and it's now called a carboxylic acid. So, COOH changes the function of the alkyl radical. Again, if CHO is attached to the alkyl radical, something new is formed and it's now called an aldehyde or alkanal. And so CHO changes the function of the alkyl radical. Now listen carefully. The OH group changes the function of the alkyl radical and makes it an alcohol. So it is called a functional group. Similarly, the COOH of carbon, oxygen, and hydrogen atoms changes the function of the alkyl radical and makes it a carboxylic acid. And so it is called a functional group. Again, the CHO group of carbon, hydrogen, and oxygen atoms changes the function of the alkyl group and makes it an aldehyde, and so it is called a functional group. Thus, we can define functional group as an atom or group of atoms which specify the chemical properties of an alkyl group or alkyl radical. It can also be defined as an atom or group of atoms which determines the chemical reactivity of an organic compound. So this is the definition of functional group. For example, the OH is a functional group and it specifies the chemical property of this alkyl radical. And so without the OH group, it is just an ordinary alkyl group. Thus, general form of any organic compound is R-functional group, where R is the alkyl radical and different functional groups can be attached to it. We shall now look at a list of important functional groups. I like to write them as 4 A's, C, and K. They stand for alcohol, aldehydes, alkyl halides, amines, carboxylic acids, and ketones. The functional group of alcohol is dash OH, for example, ROH. That of the aldehydes is dash CHO, for example, R-CHO. That of the alkyl halides is dash X, where X stands for halogens, which could be fluorine, bromine, chlorine, whichever. An example, R-X or R-Br. The functional group of the amines is dash NH2, for example, R-NH2. That of carboxylic acid is dash COOH, for example, R dash COOH. For the ketones, it is dash CO dash, for example, R dash COR. So these are the list of important functional groups used in organic chemistry, and here are their suffixes. So we shall now classify organic compounds on the basis of functional groups. For example, this is an alcohol because it contains the OH group. This is an amine because it contains the NH2 group. This is a ketone because it contains the CO group. This is an carboxylic acid because it contains the COOH group. And this is an alkyl halide because it contains the halogen group like chlorine. So a functional group could be an atom like chlorine or a group of atoms like COOH, and they all determine the chemical properties of an organic compound. I hope you have understood the concept of functional groups. Welcome back. Now that we have learned the concept of naming functional groups or the concept of functional groups, we shall now look at some examples. I will leave this here. So let's say we have a compound of this sort. Okay. Let's say we have a compound of this sort. Now, looking at this compound, this is a typical organic compound. So, since this is an organic compound, we shall look at the things contained in this compound. Now, this compound contains a functional group. We already talked about functional group. This compound contains a functional group. So let us take note of that so we don't forget that it contains a functional group. Now that we have established that the fact that this compound contains a functional group, the next thing to do is to get the roots or to get the parent chain. The parent chain is that chain that has the longest continuous carbon chain. In this case, since a functional group is present, the longest continuous carbon chain must contain the functional group. Now let us count. If we count like this, 1, 2, 3, we have 3 carbons here. We count straight, 1, 2, 3, 4. We have four, sorry, 1, 2, 3, 4. 1, 2, 3, 4. We have 4. Counting this way, 1, 2, 3, 4. We also have 4. So whichever way you want to count this compound, the longest continuous carbon chain is 4. Okay, now that we have established that the longest continuous carbon chain is 4, the next thing to do is to number this compound. In numbering this kind of compound, preference must be given to the functional group. When a compound contains just a substituent, preference is given to the substituent. But in a case whereby a functional group is present, the functional group is given preference. And by preference, I mean that the carbon atom bearing the functional group must have a small numbering. So let us number. If we number this way, 1, 2, 3, 4, the functional group is on carbon number 4. If we number this way, 1, 2, 3, 4. The functional group is on carbon number 1. So to obey the IUPAC rule, we are going to go by this. We're going to sum and numbering this way. So this one will be disregarded. This will not be considered at all. So the numbering of the compound is going to be this way. Okay, so now that we have established the numbering, we should now, it means that the longest continuous carbon chain has 4 carbons. Now looking at this, an organic compound that contains 4 carbons is known as what? A butane or butane. Let me just call it butane. So the root word here is going to be what? The butane. This is going to be the boot. Not forgetting that we have to insert our prefix, we also have to insert the suffix. Okay? So now let us start with the prefix first. The prefix, since we have already established our functional group, the prefix will now be the substituent. Okay? The substituent will now be named as the prefix. Now to name this substituent contains just one carbon. So this is a methyl. Okay, an alkyl radical, but in this case, it contains one carbon, it will be called a methyl, which you have already been taught in class.
So this is a methyl group, and the methyl group is on carbon number 4. For everything we do in organic chemistry, specification must be given, numbering must be considered, names must be given properly. So in this case, this methyl is on carbon number 3. So the prefix of this, the prefix will be of this sort: 3 hyphen methyl. Okay, so this is going to be 3 methyl groups. So we have gotten the prefix. Now, what we are left with is the suffix. So to get the suffix in this case, we have to consider a whole lot of things. We have to look at the degree of saturation or unsaturation of this compound, and we also have to look at the functional group. In this case, before we get to the functional group, let us look at the compound itself. The carbon atoms are linked by just single covalent bonds, just single covalent bonds. So because they are linked by single covalent bonds, this compound is an alkane. Alkane, okay, it's an alkane, as we already know. So this N is going to leave here and be added to this. So this will now be called a butane. Okay, so now that we have established, the next thing to do is now to get or to name the functional group. Now, in naming functional groups are named as or they are added to a main name as suffixes. It means they add to the main name, and we don't just add the whole name of the functional group. The name ending of the functional group is what is required. In this case, the name of this compound is the name of this functional group belongs to a family known as the alkanol. You can call it the alkanol or the alcohol. Okay, this is the family to which this functional group belongs. And so the name ending of this functional group is all. So which means what will be adding to this one is going to be what? All. So we'll be adding all to this. So coming back to this now, to add this all, the last E of this compound, the last E will be removed and be replaced by or replaced with the main ending of the functional group. So it means, going by everything that I have explained to you, this compound should be called 3-methyl butanol. That is adding the all. But in organic chemistry, we always have to specify position. We just have, that was the reason why we numbered in the first place. So because this functional group is on carbon number 1, this compound will now be called 3-methyl butan. Let us make room for the one. Butan hyphen, because the number is coming in 1 all. So the name of this compound is 3-methyl butan 1 all. Now let us look at another example. Let us say we have a compound. So if we have a compound that looks like this, now don't forget what we said earlier. The first thing to do is to get the longest continuous carbon chain. So we are going to count. If you count like this, 1, 2, 3, this is 3. 1, 2, 3, 4, this is 4. You count this way, 1, 2, 3, 4, this is 4. You can count like this, 1, 2, 3, 4, 5, this is 5. You can count like this, 1, 2, 3, 4, 5, 5. So whichever way you choose to count this, the longest continuous carbon chain is 5. Let us keep 5 somewhere. Okay, we have to bear in mind that the longest continuous carbon chain is 5. So now that that has been established, the next thing to do is now to number this compound. In numbering this compound, don't forget, as I said earlier, preference must be given to the functional group, which means the numbering should be done in such a way that the carbon bearing the functional group will have a small numbering. If we number this way, this is the functional group. Let us take note of that. Okay, so it will have a small number, and sorry, to have a large number. If you number this way, 1, 2, 3, 4, 5. But if you number this way, this is going to be on. This is going to be carbon number 1. Yes, let's speak something clear. Now, this is actually a functional group, but this functional group has a carbon in it. So in numbering, the carbon of the functional group will also be counted. It will be included in the number. So the number will be of this sort. So now the carbon number 1, carbon 2, carbon 3, 4, and then 5. So after the counting, we are going to get the root word. So looking at this, the root word for an organic compound containing five carbons is pent. Okay, so pent. So which means we are going to still add, we have substituents, we're going to add substituents, we're also going to add the functional group. So let us first add the substituent. Let me circle the substituent to know that they are substituents. Now, the substituents are formed, this is carbon 1, 2, 3, 4, 5. So the substituent form on carbon number 3 and on carbon number 4. So this is going to be written as 3, comma, on carbon 3, going by this. We also have 4. So don't forget that this is called a methyl. So we have 3, 4. We have ordinarily called it 3, 4 methyl. But because the methyl is occurring twice, so this will be called 3, 4 dimethyl. So we're going to put a hyphen on that because we're introducing a letter. It's going to be called dimethyl. Okay, so we have gotten our prefix and the root word. The next thing to do is now to introduce the substituent. Now, before we do that, you have to look at the compound critically. This compound contains just carbon-carbon single bond, and so this is an alkane. So because it's an alkane, we are going to add N to this. Okay? We have left it at this pentane, would have left it at this, but because it contains a functional group, the last E of this will be removed and replaced with the suffix or the name ending of the functional group. This functional group belongs to a class called carboxylic acid. Okay, this belongs to a group of families called carboxylic acid, and so the name ending or the suffix that is used to identify this sort of groups is oic acid. Okay, oic acid. So this compound will now be called pentanoic acid. Don't forget again that we also have to specify the position of the carbon. The carbon is on carbon number 1. So this will be called 3,4 dimethyl pentan 1 oic acid. So this is the name of this compound. So before I leave you, let me leave you with the last example. In a case whereby we have more than one functional group present in a compound, let's say we have a compound of this. Okay, in a case whereby we have a compound like this, now based on what you now know about functional groups, you should know that this is a functional group and this is also another functional group. So which means we have two functional groups on this compound. So since we have identified the functional groups, this one is a substituent. Okay. Now the first thing to do is to get the parent chain, okay, or the longest continuous carbon chain. Now, in a case like this, the longest continuous carbon chain must contain a functional group. Okay, it must contain a functional group. So, looking at this carbon, this is actually carbon, even though it is forming or it belongs to a functional group. This is carbon, and so this carbon falls in this chain. And so the longest continuous carbon chain automatically contains this functional group. So after establishing that fact, we'll have to number. And don't forget that in numbering, preference must be given to the functional group. So we cannot number this way because numbering will mean that we're giving preference to this. So our number would have to be done like this: 1, 2, 3, 4, 5. Okay, so this is 5. And so the root word is going to be 5. So an organic compound containing 5 carbons is called pent. So we're going to use pent. So it means we have a substituent, it means we have to give a prefix, and we have functional groups of the functional group, we have to give a suffix. Now, in this case, the name of the compound cannot bear two functional groups at the same time. It's not possible. It's just like calling a male or saying this is a man, and then at the same time calling the person a woman. Okay, so that person has to be a man who possesses some features or qualities of a female, or a female who possesses some qualities or features of a man. That's the same thing with this compound. So this compound is a compound that contains this functional group that possesses features of another functional group. And as such, functional group will now be regarded as a substituent. let me repeat myself again. The reason why this functional group is regarded as a substituent is because we have already picked a functional group for the compound. So any other functional group present on the compound will be regarded as a substituent. So let me clean this now that we know this. So let me turn this to this. So which means that this will be regarded as a substituent and will now form what? The prefix. So let us get the name. So based on our numbering, we have this, since it is now going to be regarded as a prefix, as a substituent, it will no longer be called all, which belongs to functional group. This will now be called hydroxy, which you already know that. So this will be called hydroxy. And we have a hydroxy on carbon number 3. So we're going to have it to be 3-hydroxy. We just keep this here first. Sorry, hydroxy. We have a methyl on carbon number 4. We have 4-methyl. Okay, so these are the entities that will make up the prefix. So this compound will now be named as this. We have a methyl, we have a hydroxy. The naming will be done alphabetically. So H and N, which comes first? I bet you will say H comes first. So this compound will be named as 3-hydroxy. Okay, the next one is 4-methyl. So we have only gotten the prefix and the root word. The next thing to add up to this is now the functional group. So this functional group, as I said earlier, it belongs to a group known as the carboxylic acids. And they are represented using oic acid. So this is going to be pent, because it's on carbon number 1, this is going to be pent 1-oic acid. So this is how to go about it. So please watch this video carefully and answer the following questions.